Hello my dear students, welcome back to the class. The last video we have discussed about the density. How can we find the density of the liquid? Okay, so today we are going to discussing the topic sea breeze and land breeze. Okay, land breeze and sea breeze, concept of flotation and sinking. Concept of flotation and sinking, and the next is comparison of densities in the three states of matter. Three states of matter, their comparisons. Okay, comparison of densities in the three states of matter. So these three topics today we are going to discuss. Is it clear? Okay.
So first we are going to discussing sea breeze and land breeze. Land and sea breeze are caused due to the formation of convection currents near the coastal areas due to the uneven heating of surface of land and sea water. So first of all, sea breeze. A sea breeze is the wind which blows from the side of the sea towards the land during daytime. As the sun rises and shines equally on the surface of land as well as sea, the land gets heated up rapidly as compared to sea water. The air above the land gets warmed and less dense. This air rises up, causing a drop in the air pressure. To make up for this drop in air pressure, the cool air from the sea starts blowing towards land. This is sea breeze. And next is land breeze. A land breeze is a wind which blows from the land towards the sea during night. As the sun set, both land and sea start cooling. However, the land cools much faster than the sea water. Thus, the air above the sea is warm and hence less denser. This less dense air rises up and causing a drop of air pressure on the surface of sea water. To make up for this drop in pressure, the cool and dense air from the land started blowing towards the sea. This is land breeze. I hope all of you understood this topic. Okay, so next we are going to discussing the concept of flotation and sinking of air substances. Do you think why some objects float and sink in water or if any other liquids? You have any idea about that? Okay. An object floats when the weight force on the object is balanced by the upward push of the water on the object. The upward push of the water increases with the volume of the object that it is under water. It is not affected by the depth of the water or the amount of water. Okay. Here I kept some two beaker. Okay, and object is less weight. Both objects are less weight, so it will be float. Okay, and three beakers having water and its kept the more weight, it will be sink. So in case of iron, it will be sink or float. Yes, it must be sink because of the density of iron more than the water. Okay, so the different objects float at a different level in the water because as most regular objects are lower into the surface of water, the upward push the water steadily increases until it is balanced in balance with the weight force of the object, and the object then continues floating at this level with the two forces in balance. Okay, many objects that are hollow as so generally contain air, its float because the hollow sections increases the volume of the object. That's why in our ship that's not sink in the water and submarines. Why? Because yes, inside it is hollow. You know that the ship that is made of iron. Okay, so the iron always sink in water because the density of iron that is more than the water. But in case of ship that's not sink in water, it's float. Why? Because of the hollow space inside it is hollow. Okay, so this float because the hollow section increases the volume of the object for very little increase is in weight force down. And however, it is not necessary for an object to contain air in order to float. This is because of relative density. The ratio of the density of a substances to the density of water is called what? Relative density of the substance. Okay. So this relative density represented in the letter RD. Okay. So density of the substance upon density of water. So we will get what? The relative density. So once again, can I ask one question? Why does an iron needle sink in water but not an iron ship? Any idea? Okay. So first of all, we want to know about buoyancy. What is buoyancy? Do you hear this word buoyancy? Okay. So first of all, we need to thank our Archimedes. Okay, the great scientist. Archimedes for being the first to explain the principle behind this puzzle. Archimedes was a Greek scientist who was born in 287 BCE. This principle is known as buoyancy or Archimedes' principle. Archimedes' principle states that the force exerted on an object in a fluid equal to the weight of fluid displaced. Okay, by the object. This force is called buoyant force. The buoyant force pushes upward against the object. Gravity exerts a downward force of the object, its weight, which is determined by the object mass. So, if the force exerted downward on the object by gravity is less than the buoyant force, the object will float. How do buoyancy and density apply to ships? So how can this principle apply in ships? To ships, ships are numerous steel vessels. A ship can have a mass of hundreds of thousands of tons. Steel is much denser than water, so you would think that massive steel ship would sink, right? Well, think again. What helps keep a ship float in their shapes and which is inside them? Ships are not solid pieces of steel. Instead, they are mostly hollowed out shell of steel. They are all sorts of components inside the ship. Ship sinks it is because water enters the ship. The force out the air making the average density of the ship greater than the force of water. One of the most famous disasters is the sinking of RMS Titanic. The ship struck an iceberg off the south coast of. So the air that is inside a ship is much less denser than water. That's what keeps it floating. Okay. Same case of in our submergers also. This limsol lines. Limsol lines for the safety consideration. All the ships have marking on their hull to show the level up to which they should be submerged in some particular area or river. Okay, this marking is called what? Limsol lines. Okay, clear? Okay. Next we are going to discussing that densities in the three states of matter. Okay, comparison. So in case of solid, liquid and gases, the intermolecular space that depending upon that densities. Okay. So in case of solid, the intermolecular spaces are very small and intermolecular force are very large. So the molecules of solids are tightly packed in a small volume, as we know that density equal to mass by volume. Therefore the solids have high density due to their small volume. Okay, so next we are going to discussing that in case of liquid, the intermolecular space are somewhat large and intermolecular force similarly small as compared to solid. Okay, so the molecules of liquids are not tightly packed in a small volume as compared to solids. Thus, liquids have less denser density than solid. Okay. Next, we are going to discussing in case of gases. The intermolecular spaces are 1,000 times or more than liquids. Okay, this is in turn weakness the intermolecular forces to almost negligible magnitude. The molecules of a gas are free to move in any directions and so occupy all the available space. Thus, we can say Gases have very large volume, hence they have very low density as compared to solids and liquids. Okay, so
I hope all of you understood this topic. Okay, thank you.